All right. Just double check, because I think some of you were still on your last step, maybe before or after, or right around the time when I got to you, but it should be 1.5 or 1.5. So just make sure, again, with the absolute value bars, -8 plus 3 is -5, but that you're taking the absolute value. So if you got -8.5 as your answer, you didn't take the absolute value of -5. Questions? Okay. Then solving absolute value equations is the next objective with this. So one thing I do want to say that I see most students do, and I saw some of you were working ahead on this, which is fine. You may remember what to do with absolute value equations. The absolute value bars mean something. They're there for a reason. So don't treat this as just a normal equation. It has one answer. I'm just going to solve it and ignore that those bars are there. Most absolute value equations, not all, but most are going to have two answers. So if we look at example 3, we have the absolute value of x is 8. And we talked about the absolute value meaning the distance a number is from 0. So if x, this is saying the distance x is from 0 is 8, what could x be? 8 or -8. So both +8 and -8 have an absolute value or a distance from 0 of 8. There's two answers. Now, I usually think of absolute value then as having a positive case. Notice I'm not saying a positive answer, because sometimes the positive case does have a negative answer, but a positive case and a negative case. Oops, if I could spell negative there, negative case. And all that means is you're taking whatever is inside of the absolute value bars, in this case it was just x, and you're setting it equal to the positive of the right side or the negative of the right side, and then solving. And again, in this case, it was just x, so there wasn't any additional solving we needed to do. So if we look at example 4, the absolute value of y plus 3 equals 8. So before I solve this, I should set up the two cases, the positive and the negative case. The positive case would be keep what's inside the absolute value bars the same. Y plus 3 equals the positive 8, or the y plus 3 could equal -8. So you're just changing that right side to a negative in the second case. But now this one, we do have to solve for y in both cases. So in both equations, to solve for y, we subtract 3 from each side. So if I do that to the first equation, I get y is equal to 8 minus 3, or 5. And in the second equation, I get y is equal to -8 minus 3, which is -11. And those would be the two answers. Okay, any questions on that? Keep in mind, too, you will see in certain cases, it's very important that you check your answers, because it is possible that you could get an answer that when you substitute it back in, it doesn't actually work. So I'm not requiring you to show that you're checking your answers, and it could just be a simple in your head or on your calculator. So if I just quickly checked, if I substitute 5 in for y, 5 plus 3 is 8, so the absolute value I know is 8, so that works. -11 plus 3 is -8, so the absolute value is +8. So just a quick check, because, and we will go through an example, but in some cases, one of your answers or both might not actually work. And we'll talk about that when we get to it. Examples 5 and 6 are similar with how they are set up, different in terms of what their solutions look like. So for both examples 5 and 6, notice the absolute value expression is not by itself. there's something else on the same side of the equal sign with that expression, before you set up your two cases, the absolute value expression has to be the only thing on one side of your equal sign. So the first thing I have to do, for example, in number 5, is I have to get rid of this plus 8, so I need to subtract 8 from each side. And I'm going to keep the absolute value of 3x minus 2, and now that's equal to 1 minus 8, so negative 7. So now this equation looks like the first two we went through because the absolute value expression is by itself. However, there's another difference with this particular example, and that's the fact that now what's on the right side of the equal sign is negative. So what this equation is saying is that whatever I substitute in for x, and then I multiply by 3, subtract 2, when I take the absolute value, it's saying the absolute value has to equal negative 7. We said right at the beginning, absolute value cannot be negative. So when you see something like this, this is actually no solution. And you can either write out the words no solution or just put the empty set symbol. That's what this is. All right, does that make sense? Why is it that way? I'll explain it again. So this is saying if I put any value I wanted to in for x, let's say when I plugged in x, I multiplied by 3, subtracted 2, this came out to be negative 7 inside of here. When I take the absolute value, though, it's positive. This is saying that when I take the absolute value, it has to equal a negative number, but absolute value is never negative. So if you even want to make that note in your notes, that absolute value cannot be negative. So it's simply because in the original equation, it's not in the two cases I set up, but in the beginning equation, I have a negative number equal to an absolute value, and that's a no solution. Now, let's say you forgot that. You're on your assignment, you're taking your test, you set up your positive and your negative case, you would get two answers. That's why checking your answers is so important, because when you checked your two answers, neither of them would work, and you would find that it's no solution anyway. So even if you went through the steps and you solved it, as long as you're checking your answers, you would still get no solution. Are there other questions? I can re-explain. That's an important note to make. Okay, and then for number 6, so this one is set up a similar way as 5. We need to get the absolute value expression alone first, so I need to get rid of that positive 4. So I'll subtract 4 from each side first. So the absolute value of a minus 5 is equal to 9 minus 4 is 5. So this equation now is okay. I can continue from here because the absolute value of something is equal to a positive number. So now this is the point where, since the absolute value is by itself, I can now set up my positive and negative case. So positive case would be a minus 5 equals positive 5. Or the negative case, a minus 5 equals negative 5. And then solve both of these. So to solve both for a, I need to add 5 to each side. If I do that for the first equation, I get a equals 5 plus 5, so a is 10. And for the second equation, I get a is equal to negative 5 plus 5, which is 0. So 10 or 0 are the two solutions for 6. I should check those in the original equation. So if I did substitute 10 back in for a, 10 minus 5 is 5. The absolute value is still positive 5. And if I add 4 to that, I do get 9. So it does work out. If I substitute 0 in, 0 minus 5 is negative 5, but the absolute value is positive 5, and then positive 5 plus 4 is 9. So they do both work. Okay, simple check. Takes, maybe a couple extra seconds, but then you know if your answers are right or not. So any questions before I move on to example 7? Yes. Yep. Yes, so this would be what I consider like the negative case. Yes, yes. So that's where the very first step is just getting this alone. So notice I kept the absolute value bars. And then when I'm taking this and splitting it into the two cases, the positive and negative case, I no longer include the absolute value bars. So the first case is basically just rewriting the equation without the absolute value. And then the second case is changing this side to the opposite. Other questions? Okay, 7 I'm going to go through with you, and it is set up a little differently because notice on the right side of the equation you have an expression and not just a number. And then 8 I'll have you do without me, and I can walk around and check and answer questions. Just make sure that we're all good. So 7, the absolute value expression is already by itself, but notice it is set up differently from the other examples. We have a whole expression on the right side, not just a number. That's okay. But I don't have to do what I did in this first step for the above two because this is already by itself. So I can go straight to setting up the two cases, the positive and negative case. So the first case is just keeping the whole equation the same. I just don't need the absolute value bars. So I have x plus 10 equals, and I keep the right side the same, 4x minus 8. The second case then, I still keep the x plus 10, but it's the negative case, or the opposite case, so I need to take the opposite of the entire right side. So there's two ways you could write that. You could write it as I'm taking the opposite, or negative, and then in parentheses, put 4x minus 8. So I'm taking the opposite of that whole side. Or you could say right away, I need to take the opposite of everything, and it would be the equivalent here of distributing that negative sign. So I would have negative 4x plus 8 on that side. So just make sure in that negative case, you're taking the opposite of the entire side if there's more than just one number there. Questions on the setup part? Okay, and then you solve these both for x. So I'm going to go back to the first equation and solve for x. There's 4 different first steps you could do. I'm going to subtract 4x from each side first to get the x's on the same side on the left. So I have 1x minus 4x, so negative 3x plus 10 equals, and I still having negative 8 on the right side. And then I would have to subtract 10 from both sides. So negative 3x is equal to negative 8 minus 10 is negative 18. Divide by negative 3, and x is 6. Positive 6 is one answer I get. Just put an or here. Solve the other equation. So for this one, I'm going to add 4x to both sides. So 5x plus 10 is equal to 8. Subtract 10. 5x equals 8 minus 10 is negative 2. And divide by 5. I'll write it over here. X would be, and I could keep it as negative 2/5. Or if you wanted to write a decimal, it is a terminating decimal. It's negative 0.4. That would be okay. So these are the two answers I get, 6 or negative 0.4. Now this one, and I just know this ahead of time, I picked this example on purpose. If I were to not check my answers and I just left this, my answer is wrong. Because one of these doesn't actually work. And I'll explain why. So I'm actually going to show the check for this one because one of them is not going to work. So if I checked x equals 6, so anywhere I see an x, I'm going to substitute in a 6. So I have the absolute value of 6 plus 10 equals 4 times 6 minus 8. And I should actually, I'm just going to put a question mark here because I'm checking to make sure the two sides of that equation are equal if I substitute in 6. So on the left side, I have 6 plus 10, that's 16. The absolute value is still positive 16, so I have 16 over here. And then on the right side, 4 times 6 is 24, and then if I subtract 8, that is also positive 16. So 16 equals itself, that works out. So x equals 6 is a solution. So then if I check x equals negative 0.4, I'd have the absolute value of negative 0.4 plus 10. Does that equal 4 times negative 0.4 minus 8? Make sure the two sides equal each other, and if they don't, then it's not a solution. So negative 0.4 plus 10 is 9.6. Absolute value is still positive 9.6. And then 4 times negative 0.4 is negative 1.6, but I'll show it on here. 4 times negative 0.4, negative 1.6, and then if I subtract 8, that's negative 9.6. Okay, and 9.6 and negative 9.6 are not equal. So this is what we call an extraneous solution. And what that means, and this just happens sometimes with absolute value equations, it means that the two cases we set up, which we set up correctly, the two cases we set up to solve the absolute value equation, the negative 0.4 was a solution to that equation, but it's not a solution to the original equation. And that just happens sometimes. So this is not a solution. Extraneous really means false. So the only solution is x equals 6. Okay, so check your answers. It's very important too with no solutions. Like I said, if you were to not recognize right away that an equation is no solution, you would find that it's no solution when you check your answers and they both don't work. So just make sure you check, because if you leave a problem on the test, you just leave both solutions and it turns out it's no solution, your answer is wrong and you'll lose points. So it's, quick, just make sure you check. So I have example 8. This I'm going to leave for you to do without me. One thing I do want to say before you get started is it looks like that negative 3 could be distributed. You cannot distribute inside absolute value bars. You can distribute if it's parentheses, but not if it's absolute value bars. So I'll just say that first. So go ahead, solve number 8.